Right, so in this video, we are going to look at an example of application of Euclid's division algorithm to find the HCF of two numbers. Now the question says that use Euclid's division algorithm to find the highest common factor of the numbers 4052 and 12576. Now let's apply the step one by one. Now if you remember in Euclid's division algorithm, to a given pair of numbers, let's say C and D, we apply the Euclid's division lemma such that C equals DQ plus R, and we keep on applying this iteratively till we get a remainder equals to 0. That is the whole idea. So this is the Euclid's division lemma. Now in this case, the first step is we clearly need to apply the Euclid's division lemma to these two numbers. So we start with, since 12,576 is greater than 4,052. So 12,576 is greater than 4,052. So we start with applying the Euclid's division lemma to 12,576 equals 4052. Now you can see 4000 times 3 is about 12,000, so we'll just try that times 3, right? And when we solve like 3 times, okay, so this gives us a number close to 12,000, and when we add the result to 420, we will get the number 12,576. So this is the first time where we have, this is the number C, this is the number D, this is Q, and this is your remainder R. Now R equals 420, so this is not equal to 0. So we need to apply this again. Okay, so but what we need to do is we need to apply the division lemma to the numbers 4052 and 420. This is what we apply. And since 4052 is greater, so we go 4052 equals 420 times 9 plus 272. Okay, this is our C, this is the number D, this is the number Q, and this is the number R. Now in this case, the remainder that we are getting is 272, and this is not equal to 0. So we need to apply the Euclid's division lemma to the numbers 420 and 272. Okay, so because 420 is bigger, right, so we say 420 equals 272. Okay, if we do 272 times 2, then it becomes bigger than 420, so we'll just say 272 times 1 plus 148. That gives us the remainder R equals 148, which is not equal to 0. So we again apply the Euclid's division lemma to the numbers 272 and 148. That's these two numbers. So 272 equals 148 times 1 plus 124. The remainder we get here is 124, not equal to 0, so we need to apply the Euclid's division lemma again to the numbers 148 and 124. And therefore, we can say that 148 equals 124 times 1 plus 24. The remainder R is equal to 24, not equal to 0. So we need to apply the Euclid's division lemma iteratively to 124 and the number 24. So we have here 124 equals 24 times 5 plus 4. The remainder R is equal to 4. So we need to apply Euclid's division lemma to these pair of numbers 24 and 4. So we have 24 equals 4 times, how much is 24? 6 plus 0. So we get R equals 0. And that is where we stop. So now the remainder has become 0. We don't need to move any forward. And the divisor at this stage is the number 4. Okay. So the HCF of 12,576 and 4,052 is the number 4. Now you have to notice one very important aspect here is that 4 is the HCF of all the pairs that we consider together. So 4 is the HCF of 24 and 4. It is also the HCF of the numbers 124 and 24. It is also the HCF of the numbers 148 and 124. It is also the HCF of the numbers 272 and 148. It is also the HCF of the numbers 420 and 272, and it is also the HCF of 4052 and 420, and it is also the HCF of the original numbers that we started with, that is 12,576 plus 4,052. So that just shows why when we iteratively apply this division lemma starting from 1 to up to 7 times, we get this answer 4. So in summary, the Euclid's division algorithm is not only useful for calculating the HCF of very large numbers, but it's also one of the earliest examples of an algorithm that a computer had been programmed to carry out, right? So it becomes very easy once you write a function in a computer to just keep on asking it to iterate over it till you get the remainder equals 0. Now, a couple of things to keep in mind, that Euclid's division algorithm or the Euclid's division lemma and algorithm are so closely interlinked that people sometimes often call the lemma as the algorithm also. So they are used interchangeably. So this is something to keep in mind. And second, the Euclid's division algorithm is stated only for positive integers. Keep in mind that it can be extended to all integers except 0. So you really, so basically the number b cannot be 0. However, we are not going to discuss that concept in this video, right? So there are going to be many applications of the Euclid's division algorithm, and in the next video we are going to find this Euclid's division algorithm to extract some of the useful properties of numbers.